Hello, I wanted to show you what is called collatz conjecture. Now, many people have talked about this, but everyone says, wait, this equation is technically impossible because every number it always ends up in a loop. Now, if you don't know what I'm talking about, let me catch you up to date. So I'll show you what my code does, and then you get an understanding. So if your number, which is the number you type in, that you get from typing in, so you can type in a number, and then after you type in the number, it'll look through the number and it'll detect if it's even. This detects if it's even because it's looking at the remainder, and the remainder is 0 after dividing by 2. If the remainder is 0, obviously it's an even number, right? So it's even. But for even numbers, you have to divide the number by 2. Now, if otherwise, if this isn't true, it's an odd number, obviously, which you don't really have to write an if statement for that. So what you'll do is you'll multiply it by 3 and then add 1 to it. Now, people say something about, now, let me show you what the loop they're talking about is. So let me just do some stuff real quick. I've ran this program before, so let me show you something. So here is the Windows System 32 that I pulled up. It will help me show you what I'm talking about. Now this just does it on a console. So here's the console. I pulled up the console, and let me type any number. I'll type 69,420, and if I could get my laugh in 7 business days, that would be great. And see, what happens is it keeps on running for it keeps on doing this. It writes 1 4 2 1 4 2 1 4 2 1 4 2. Now let me show you more of why this is happening. All right, so here's the number. I'm not gonna count all of this if you didn't know. um I just didn't want. It would just be annoying for this video. Definitely not because I'm a lazy piece of shit. But anyways, here is where it starts. It starts to go into the loop. So I'll start from 160. So 160 even divided by 2, 80. 80 divided by 2, 40. 40 divided by 2, 20. 20 divided by 2, 10. 10 divided by 2, 5. 5 odd, so times 3 plus 1. 16. 16 divided by 2, 8. 4 divided by 2, 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 2, 1. 1 odd number. 3 plus times 3 plus 1, 4. Now that keeps on looping, right? As we could see here. And the theory is that, well, every number in existence is going to keep on looping like this. But is that really true? So I'm going to show you something. Now, let me show you the definition for all numbers. Even slash odd only applies to integers, negative, 0, and positive. And the theory is that this doesn't work for anything. But what about negative numbers? Negative numbers should work with this. And let me pull up the theory. Collatz conjecture theory. Collatz conjecture says that an orbit under F and uh, and then divide away the highest power to get number 2. Keep repeating this oscillation and hit 1. Simple state the problem is unsolved. Multiply 3 and add by 1. They say it's unsolved, right? But the problem is if negative numbers can be odd and even, then this statement can still work. So let me boot it up. Let me boot it up. Let me just boot it up. All right. So let's run a negative number. Let's just negative 3. Let me, you know what? I'll do the same number so that I can get extra laughs for my boring, stupid personality. So anyways, look, it's running. Wow, 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 look, it's running. Let's open it up. Woo, let's open it up. Wow, okay, let's scroll down a bit. Alright. Alright, look, 69,000, let's scroll down. And let's get to, oh yeah, okay, around here. Let's start at negative 50. Negative 50 divided by 2, 25 times 3 plus 1, 74. 37. 37 times 3 plus 1, 110. 55 to negative 55. Then times 3 plus 1, 164, 82. Then to 41. Then times 3 plus 1, 122. Now you might be like, wait, times 3 plus 1, that doesn't, times 3 plus 1, shouldn't that be 123? And then plus 4 plus 1 would be 124. But no, the reason why this doesn't work is it actually starts minusing by 2 in when you go to negatives, because it's a negative number and it takes away. So this, it doesn't actually loop for 1, 2, and 4. And this isn't the only negative number that works like that. Let me delete all of that. Alright, let's run the program again. And I'll pick any random negative number. You know what? Negative 13. Look at that. Alright, it's ran. Let's open up collatz conjecture. Look at that. All of these numbers, none of these numbers are 1, 2, 2, and 4. So basically what I'm trying to say is the collatz conjecture, or the idea that 1, 2, and 4, every number is going to be 1, 2, and 4, and it's eventually always going to loop to that number, isn't actually true. It's a false statement, and I'm not sure. And the theory doesn't state that it can't be a negative number. So by technicality, I have solved collatz conjecture, an unsolved problem. Now, maybe the Google is lying to me and that isn't actually a negative number, and negative numbers don't count. But if by what I'm going from Google, which it has multiple sources saying the same thing, let me pull it up. Collatz conjecture. Negative numbers. Okay. So these state that any positive number, but technically there's also some saying that no, that isn't true. So I don't know what to believe, but if it is true that it doesn't act, that they aren't talking about just positive and negative and whatever numbers, it would stand by that any negative number counts as not looping. So if you go by that rule, the collatz conjecture is solved. If you go by the rule that it can only be positive integers, well then no, but a lot of sources don't say either option. So that is my take on how the collatz conjecture can actually be solved. I hope you enjoyed watching. If you want, I can link the code. I can put a link. I can copy paste the code as a comment, and yeah, I'll copy paste the code as a comment. And don't forget about that laugh in 7 to 5 business days. Actually, now I kind of want that more. But anyways, goodbye, and please let